So previously in the earlier lesson, we talked about how to use Q and different concentrations when we're talking about an E value that's not at standard concentration, standard meaning 1 molar. So it's kind of like if you were using K or everything being 1 molar, then the natural log portion of this disappears and it makes this whole term disappear. So when we have things that aren't 1 molar, that's what we dealt with before, and we also were changing temperature. So we were changing this and this. If, though, we have the temperature is always the same and we're only changing Q, there is a simpler form of this equation. So what we're going to do is take the RT over N part of the equation. So I'm leaving RT over F part of the equation. I'm leaving N out of it, okay? So N is not, because N can change depending on what the reaction is. But if we take those and we multiply them, then we get another number. So if we do 8.314, and that's our R term, times, and this would be standard temperature, 298.15 over Faraday's constant, and this is the full numbered Faraday's constant, so it's 96485. If we multiply all those numbers, we get this. So 8.314 times 298.15 divided by 96485. So we get this number. And that seems simple enough, but for whatever the reason, it was decided to also convert natural log to log. And you may or may not have known that you can do this. To convert natural log to log, and hang with me because I've got one final equation that's an easier equation, and it really is worth it. But to do that conversion, you actually multiply, the number is 2.303 times the natural log part, and that will convert into a log term. So we're going to multiply this number times 2.303. And what we get is that times 2.303, and then we get this number. So this is what this equation becomes in that set of circumstances. And this is a very common set of circumstances. It becomes this. 0.0592 over that times the log of Q. So if you look at that term, that's actually way less numbers to put in. Can you see that? So you can use this if it's just different concentrations. You know, in the problem, it would be giving you concentration somehow. So it's just when you have different concentrations, but it's at room temperature. You can use this version of it. You just need to know what N is, and you just have to figure out the concentrations. So I really highly recommend using this form and that set of circumstances because it comes up a lot, room temperature, different concentrations.